All right. So again, welcome. My name is Alex Turner, and I am the program manager for the C# and Visual Basic compilers at Microsoft, helping make all this cool stuff you guys have been seeing a reality. And I'm here today to talk about specifically the future of C# and Visual Basic, and in particular the async language feature that's coming up. Have any of you guys had a chance to try out Visual Studio 11 or the async CTP and get a chance to poke at the async language feature yet? All right. Well, this will be cool then. You get to see what's coming up and what we're really planning for the next version of the language. Really, the point that we finish up here, hopefully you guys will have a good sense of what async is really all about. And what it means moving forward in terms of language innovation, and really get a sense for how async makes this idea of connected programs easier to write. And it sounds kind of like a marketing term, but you'll sort of see what I mean by that. And really, it's just these sort of core ideas, the fact that asynchronous programming at this point has really become pervasive. And we'll talk about exactly what asynchronous programming means. Different people have different definitions. But we're starting to see a big shift in the way people program across many languages. And you're starting to get languages like JavaScript that pop up where a lot of things you want to do, you just have to do it in this asynchronous way. We think we're finding good ways that we can actually change the languages at the core so they can support that much better. And importantly, if you've ever done any asynchronous programming, the async language features are all about no more callbacks, getting rid of callback-based programming for asynchronous stuff. So, I mean, just to give a sense of where things are, I know a lot of you guys are already using Visual Studio.net and everything. If you look back at where C# and VB have been, you think back to C# 1.0 and VB 7, that was when .NET first came out. It's about 10 years ago now. And that whole idea then was managed code, having garbage collector and having all that stuff handled for you. And so that was great. We moved on, though, from that. .NET 2 introduced this idea of generics and sort of baked that into the language. You could have generic collection classes and so on. C# 3 and VB 9 was this whole idea of link and having this declarative model in your code where you could run queries and you could operate against your data the way that you want to. You didn't have to think, oh, exactly how am I going to operate this query? How am I going to shape it so it can run? You think more about what you want instead of exactly how you want to do it. And then for dynamic, right? I mean, you're seeing a lot of dynamic languages come about, and you're often, even when you're within a static world, sort of talking to something dynamic. Maybe there's an object model you're talking to that's dynamic, or you have some other language. Maybe you have some code written in Python you want to call into it. And you have these islands, which are hard to talk to from each other, right? And you have sort of C# code. You have to interop in some way. Maybe you shell out to it, ask it to generate you something. There we go. My microphone is dynamic, apparently. But yeah. Is that working? Hello? Is it working? All right. Yes, my microphone is apparently dynamic as well. Yeah, and so basically the idea there was just how can we make those worlds more interoperable? So you have a static type system, you want to go talk out to the dynamic type system as well. And also C# and Visual Basic had different features at the time, right? You have this notion of optional parameters in Visual Basic, and C# already had this idea of C# already had certain things like iterators, which we're starting to bring forward now. So we really had these sort of divergent paths the languages were taking. We thought there were different customers. Hey, C# programmers want this, and VB programmers want that. It turned out in practice, every time we'd add a feature to one, people from the other language would say, well, hey, when are you going to add that feature and let us try that too? So we made an explicit effort to start bringing those things far closer together. And if we sort of look where programming languages are going, we talked about dynamic programming. I mean, there's also this idea of declarative programming, right? So you have languages where you're really specifying what you want to do in this more descriptive way. There's this idea of domain-specific languages becoming really popular, where you define some language that's specific to a business problem you want to solve. And then you can actually have domain experts, like maybe experts in financial modeling, go describe some solution and explore some space. And they don't have to think like a programmer there, right? So the developers are actually providing that bridge between the two worlds. And then you also have concurrent programming, right? Like this is something that's becoming more and more important. This is, this idea of parallelism is becoming more pervasive. You think of Moore's law, right? get more computing power, doubling every 18 months. Well, Moore's law is not dead, but individual cores that are on your system are not actually getting faster anymore. You're just getting more of them. Right? And so back in .NET 4, we had this whole push for the task parallel library and for actually coming up with better ways to do things in parallel and be able to track all these tasks and these things that are in flight. So we had all that, and that's sort of where we were. And we took those trends. We were looking forward to figure out where things were going to be in the future. And we really saw that the trends were looking the same, but there was this focus that was shifting toward that concurrent bucket, right? And concurrency means many things, right? You think of what I was describing before, this sort of parallelism in terms of concurrency, and we addressed that pretty well. But you're also starting to see this idea of increasingly connected applications, and this is coming to the fore now. You have applications where latency is a larger and larger issue. Think of mobile phones, right? Mobile phone applications are getting huge, and the problem with mobile phones are many-fold, right? You have a device that has intermittent connectivity, it has less reliable connectivity, but at the same time, with a mobile phone, people expect even better UIs than they have on the desktop, right? They expect things to be 60 frames a second constantly and to react instantly to their touch. You actually have more of a UI constraint on a phone because it has to exactly follow your finger. You have time for something to render when using a mouse on a PC, but people expect things to be even more instant on a phone. So less powerful, better UI expectations, and also higher latency due to the connectivity. And even on the server side, you're not escaping it. You also expect better scalability. We saw all the stuff going on in the cloud, right? And it's that whole mantra of pay for what you use, right? And that's critical. But you want to pay as little as possible, right? So you, at that point, want to use as little as possible. And so you want to be able to make best use of the VMs that you've got. And so you want to scale really well and not waste threads, not waste CPU power when you could be doing stuff. So the solution to this is really asynchronous programming. And it's not something that's new, right? Asynchronous programming has been around for years. And it's this idea of keeping your app responsive by making the best use of the threads that you have, right? So you think on the client, you think of something like JavaScript or Silverlight. For example, in Silverlight, you want to make a network request. You're only able to make that network request on the UI thread. That's the thread that interacts with the browser that's able to ask the browser to do a request on behalf of the Silverlight applet. But at that point, what do? I can't block waiting for that request to come back. And so Silverlight has removed all blocking APIs like that. They've removed the synchronous network API. So what do? I have to kick off a request, and I have to schedule a callback and schedule something to happen when that request finally comes back. And so that means that I have to have this kind of detached style of programming that we'll see on the next slide. Or the slide after. So basically, asynchronous programming is this idea of doing this kind of callback-based programming, but it's kind of painful. And hopefully, in a bit, you'll get a sense for why it's painful today and how we're improving it. And so we really feel this is the time to make language-level innovations to try to push this forward. So just so we're all talking about the same thing again, let's talk about a concrete example. So you think of synchronous programming. And the idea with synchronous programming is you wait for a result, right? Just normal method calls, normal programming the way you're used to. I call a method download string. And the idea is I give it parameters, and it's going to come back with a string. And it's going to return it to me. So this method wouldn't actually return until the string is available. So, obviously, that's the kind of thing I could do on a background thread, but I don't want to do that on the UI thread. So for asynchronous programming, I have to do something different. I maybe pass the same parameters, but then afterwards, I'm passing in some sort of delegate. In this case, I'm passing action of string, right? And I'm saying, well, I'm not going to use your string right away. I'm actually going to just tell you, here's what I want to do once a string is available. Right? And then, because the string might not be available for 5, 10 seconds, a minute or something, I have to return void right away. I can't return string. I don't know what the string is immediately. I have to tell you what to do later once you have it so I can move on. And so, you see the string is surfacing in a different place. And, it still kind of makes sense when you look at the signature, but it gets to be harder to interact with. But you get benefits for that, right? You get UI responsiveness. These methods are always returning. It doesn't matter how long it takes. The method's going to return right away, keep my app responsive. And that's if it's on the client. If I'm on the server, I get this scalability. Usually a blocker on the server, a limiter in terms of how much you can scale, is how many request threads that you have that you can actually handle at once. And maybe you hit 100, and then that's the most your server can do, because each thread actually takes up, let's say, a megabyte of stack. if you can make better use of that, if while that server is waiting for some other server to give it data, if it could free up the thread and allow a different request to use that request thread, that means your server can be far more scalable. So let's see sort of what this kind of stuff would look like, so we know really what we're talking about here. So in that synchronous case, you're calling the string returning version, right? You call download data, it gives you back your string, you go and you process it. So you call download data, that's fine, and in that interim period, this is the thread you're on, that thread is blocked. You can't do anything, process data comes back, now you can move on. On the alternative side, you have the async version, right? You're calling download data async, and you're giving that thing a delegate. And you're saying, all right, well, when the download is done, take some data in as a parameter and go ahead and process it, pass it to process data. So you're sending in a Lambda expression of what to do. And the idea here, though, is I kick off my download, but then in that intervening period, my thread is free because my method returned immediately. It was void. And only later, once the data is available, does my thread's scheduler actually go back and dispatch that and say, hey, now it's time to go process the data and pick up where I left off by running my delegate I gave it. And the idea is that in the bottom case, my app gets to stay responsive. If you assume all these green things are different UI messages, me moving the mouse around or tapping on a phone screen, I'm able to continue using my app and keeping it responsive, whereas all those messages would be backed up if I was in the synchronous case, right? So it's important to keep your threads free. Another side benefit you get is the fact that, well, what if I want to do another request? Well, in Silverlight, let's say, or I'm in some platform, like in JavaScript, I only get to do these one thing at a time. If they had, for some reason, given me a synchronous network API, once I was doing one of those requests, I couldn't do another one because it would be blocked. I wouldn't actually have access to the thread anymore. None of my code could run in the place where it has to do the request. But if I'm in the asynchronous case, the moment I kick off my first request, I'm in control again, and I can go do another request. And so you can get that sort of easy parallelism just by retaining control of these important threads. So let's take a look at a UI for a simple app. It'll be a synchronous UI at first, and we'll see sort of how you could make things asynchronous today, right? Because asynchrony exists. Here I'm talking about it. I showed the Lambda thing. You could say, well, we have a solution. Maybe that's good enough. We can go home and just do things that way. But when you start to see, after you get past that initial level, what it really means to start using it in an app that has more than one method, you'll start to see where it breaks down. And really, we think we can add a lot of value there. So I'm going to go back in here. And I have a simple app, which I'm going to run. And what this app does, you enter a year and pulls movies from Netflix, US movie service. You search for it on the web, and it goes off and it pulls a bunch of titles, right? And so you can see here, it pulls the titles. I can scroll through, see a bunch of movies that are from that particular year. But you noticed that it took a while, and then suddenly all the movies appeared at once. And if I search again, you see I have the toilet bowl of death, and I'm not actually able to move my window until finally all the results come back, 10 at a time from the server, and I have my full list and I can show it. And so, it sort of works, but imagine this was a component of a larger app, and maybe people, while the movies are loading, expect to scroll somewhere else, or they expect to be using menus, or maybe they want to cancel. They say, I don't care about this anymore. I want to go back. So you can't really, in a real app, be blocking the UI for that long while things are happening. So we know we need to make this asynchronous, and let's see what that would actually look like today. So, all right, if I look at the structure of my app, I've got load movies here. So this is going to be called when somebody pushes the button. And it goes through, does some simple stuff. It does some initialization, saying here, right, setting up pages. And now I'm going to go into the core of my app, right? I'm going to loop. I'm going to start looping through. It's a while loop, pretty simple. I'm updating the status text, and then I'm actually doing a query, right? This is going to call my query movies method and do one query. This OData API that I'm calling, it only allows me to request 10 movies at a time. So I'm going to go through this loop, request movies. When it comes back, it tells me the next URL. After I process it, I go make the next request, and so on. I make these requests in sequence. OK, so then I'm calling query movies. If I get back at least some movies, then go ahead and display them, and then add them to my count, and then just keep looping and doing that. Pretty simple. And if I go to query movies, I see what that's returning. Well, here we go. It's returning a movie array. Makes sense. I give it the stuff I care about. It goes out, uses web client to make a network request, and actually downloads the string. And gets the movies, uses here link to XML to munge the XML, process it, get back a result, a set of movies, creates the 10 movie objects, and returns them back where they came from. So here we go. It's pretty simple, and it's synchronous code. I have one method calling another. It's what you expect. So the core where my app is hanging is this method here, download string. This is the method that's going to do the network request you saw before to actually finish these up. In total, it was taking like 5 seconds to complete all the different network requests. So this is a method we have to change from a synchronous version to an asynchronous version. So if I look at what download string APIs are available, well, there's download string and then download string async, right? It's the same kind of dichotomy I saw before. I'm going to go ahead and call download string, so that sounds good. But you see that I'm now getting an error, right? Remember, it says I can't assign void. Download string async is going to return void because it doesn't have the movies yet, so there's nothing to give you. There's no movie array to hand back. So instead, you saw before I was taking a second parameter. Download string async works a similar way. Instead of a delegate parameter, it has an event. So you say here client.download string completed. And this is an event that I'd say, plus equals. And I'm actually going to then provide an event handler. So I'll say, all right, let's go and use this code. And then this will be the code that actually handles the event, right? And then we'll, right, so I'll get rid of this because it's not going to return anything, and I'll move this down here. So after I've subscribed to the completed event, I'm going to kick off the request. Now there's a few things left. One, I don't get data anymore directly from the call. I have to pull it in from the event result. So I'm going to say here, var data equals e.result. All right, so I pulled the data in from the event args. That's fine. And down here, though, when I say return movies.to array, now this is how I was originally returning movies, right? For query movies async was going to return a movie array, but again, I can't return that because I don't have it yet. At the point that I've kicked this off, I don't have any data to give back. So really, if I'm going to make a query movies async method, it's going to have to be void in that same way. And so what do I do? Well, I could make my own event, or I'll actually instead do what I saw on the slides. I'm going to just go here and say, pick a delegate type. I'll pick action of movie array. This will be a delegate that takes or returns a movie array, rather. And so the idea here is that whoever calls me is going to tell me what they want to happen once I have the movie array, and I'm going to hand the movie array off to that delegate. And so now here, instead of returning movie array, I'm going to say here action, and I'm going to pass the movie array to it. So, look, I had to change a few things. I had to make this Lambda expression and pipe my data through. I had to come up with an alternate way to get my result out of the method. Things are kind of in shape. It's still in generally the same order. The only thing that kind of really went out of order was this, which kicked off the request. That kind of moved after the thing that was, or the set of code that wants to run afterwards. But that's fine. I could still understand this, right? And if this was the only transform we had to make, then probably this is fine. We wouldn't need to think about new stuff to do in the language. But let's see what happens now when we try to call this from load movies. So up here in load movies, obviously I'm going to have to call query movies async now instead of query movies. But query movies async is now void, right? So it's not going to actually have a movie array to give back. So instead, I'm going to be specifying this delegate. All right, here's what I want to do when I get the movies. Here's what I want to do when I have that available. But what do I actually write here? If I think about the code that I want to run here, like remember before I just said, the last half of the method, that's going to be the contents of my Lambda expression. That'll be the delegate to run. But what is the last half of the method here? It's going to be the rest of this particular iteration of the while loop, plus all future iterations of the while loop. And then when that's done, it's going to be the stuff that I want to happen at the end. So how do I capture the last 80% of the execution of my method in a delegate? So it turns out this is actually pretty tricky. I have the code here. I'm not going to have you watch me write that on stage. Let me just delete this. I'm going to paste this back in here. And what this does, this is now split into two methods. I'm coming in here in load movies. You see the same stuff at the beginning, but then I'm calling this load movies implementation method. And I'm going to pass this stuff in. I'm going to say, well, so far, my movie array is null, and I'm going to start from there. And then I've sort of flattened my while loop out. I've shattered it into these different pieces inside load movies implementation. You see that the beginning of my while loop is actually down here. I skip all that previous code the first time through, and I say, all right, well, once we're in here, take the status text, set it up, and then call my query movies async method. And then that delegate I give it is just going to be this little shim I have here that says, all right, well, when you get more movies, call myself and pass me the movies that I got, right? And then, as I do that, it's passing next movies back up here. I'm going here saying, all right, well, if I got some movies, then go through and process them. So now I'm going to say, all right, display those 10 movies that I got, add to the image count, and then I have to go back and do it again. I have to fetch some more movies, query again, and then basically keep looping back around manually by calling back into my own method. I'm having to use this kind of lambda recursion to fake having a while loop. A pretty basic concept. And only finally, when I'm all done, that I come back and have a movie array, but it's empty, do I finally say, all right, I'm done. Here's the code that I want to do at the end. So you think of the while loop that I had before. I had some code at the beginning, which was here. I had some code in the middle, which is now here. And I had some code afterwards, the end of the while loop, at the very end of my method, which is now here. So my entire method got turned upside down, shoved into all these if statements. I had to split it into these two methods so one could sort of do this recursion and like fake up a while loop. And this is just because I had two methods, one that called each other and involved the simplest looping constructs, right? So you can start to imagine how when you get into a bigger app, maybe you have 20 different classes and you have things calling each other, right? It suddenly becomes a huge mess. And you can rig this up with events, and you can start to rig this up with callback delegates and so on. But it starts to become really, really annoying. And we'll actually see, so let's try one more thing. You could maybe imagine maintaining this code moving forward, but what if we want to make this even more robust and handle exceptions? What if there's an error that surfaces during query movies async? Well, let's take a look at where errors can come from, right? What could fail? Well, client.downloadStringAsync could fail, right? I pass it a URI. Maybe for some reason that URI is bad. I got it from the previous request. Maybe they gave me a busted URI. So downloadStringAsync itself could fail. So where else could fail? Well, let's say the download completes and it comes back, but it comes back with an error. Like it's actually able to kick off the download, but the page is missing or the server's inaccessible. So I'd have to go up here and start thinking about that. All right, well, if e.error equals whatever, and I'd have to start testing for errors up there. That's a second place that errors can surface from the actual result object that comes back from the exception, from the asynchronous request. And then, let's say I make the request, it's valid, I get back the result, and I actually get a result back. But then when I'm parsing the XML, maybe they gave me invalid XML, right? So as I'm parsing it, I'm going to have a parse error. So here's actually a third place that errors could surface. So I'm going to have some sort of try-catch here, another try-catch around this. This actually isn't even a try-catch. I'm manually checking errors. So I have these three places where I have to start thinking about errors and error handling. And this is just from doing one asynchronous call. Imagine if this method called something which had to call something else. You have to make a bunch of requests in series. And so it quickly starts to fall apart, actually making a maintainable app that's doing all this asynchrony stuff, right? People do it. You have to do it if you want to make a responsive app, but it becomes really painful. So let's just hold down Control-Z and undo everything we did. And, well, you have to hold Control as long as you hold Z also. And we'll think about what we want to do now instead and what the language could actually do to help us here. So we were talking before about .NET 4 and some of the stuff .NET 4 introduced around task parallelism, right? It introduced this idea of the task type. You may have played with this. It's this type that lets you represent a unit of work that you can then send off to be executed in a thread pool or some sort of scheduler and say, hey, when this work is done, I want this thing to be continued with, right? So somebody can do work, give you a hold of this sort of handle on the work, and then you can hook up continuations to that. So you can say, when this work is done, kick off this other work, use the result to sort of fork off, join back, and think about your work at this higher level. And it's really cool and useful when you're doing this kind of task parallelism. But what we realized was this same type actually serves a lot of the purposes we need for something that will help us make async programming, even just in the client, a lot easier. So if you think what I want some sort of query movies async method to return, we tried the method where we have a parameter passed to it with a delegate, and that quickly became cumbersome. So we do want some sort of return value, but we know it can't be a movie array. A movie array is just going to be not valid because I don't have a list of movies yet. I'm only going to get my list of movies later on. So that's not going to work. Well, what I really want to give somebody is something they can get immediately, but that object will later be filled with a movie array, something where ultimately I'll tell them, hey, by the way, your movie array is now ready, and they can handle the notification themselves. And so this task type actually serves that purpose. If I say I want a task of movie array, task of T, it's generic, this basically says, all right, it's a promise that in the future a movie array will be available to you, or an exception that says why you couldn't have the movie array. But it's going to give you that immediately, right? And so, all right, that could be my return type. That works. But what do I actually do here? I didn't like calling download string async. It made things hard. if I look what else I can do, there's download string async, but there's also this extension method, download string task async. And this is part of this async CTP that we have that we've put out there for you guys to try out, our new language support. And it provides these task returning versions of a lot of the async APIs that are out there today. And so versus being a void method that has some associated event handler, instead you see that it takes the same parameters that download string does, but it returns a task of string. And so now by calling this, I'm able to get back a task and I can operate on it. But still, if I think what I'd have to do with a task, we talked about signing up continuations. I'd have to say, all right, well, when the task comes back, you can call continue with on it and have that continue. But it would be kind of like hooking up all these delegates. I'd be doing what I was doing before anyway. So how do I make that better? And that's really where all this language support comes in. So what I really want to do is I want to turn this method into a method that can pause its execution when it gets somewhere that it's going to have to wait. I want this method to relinquish control of the thread that it's on so that the UI thread can be free, people can move the window, scroll things around, and then only come back to this particular place in the method once the data is available, once that asynchronous operation completes. And so the way I do that is by turning this synchronous method into an async method. So async, which I put on my method, this is a new keyword we have in C#5 and in Visual Basic 11. And this is what lets you actually make these kind of automatic state machines and have the compiler do that work for you to construct it and turn your method into this pausable, resumable method. So I say async up there. And I now go on, code my method as I normally expect. And then when I call something that gives me a task, something that I could await to figure out, hey, when it's done, I want to continue, I put in the new await keyword. And so I've made my method an async method at the top, and then here I put in await. And you see that's all I had to change. The compile errors are gone. So download string task async returns a task of string, but when I hover over var, data is now getting back a string. So await is going to say, go ahead, wait till that's done. It could be 5, 10 seconds, a minute later. When it's done, pick this method up where it left off and keep going. And by the way, extract the result out of that task and give it to me. And so this now lets my method continue. And when it's all done, and I say, all right, return movies.toArray, this is going to give me a movie array, package that up into the task of movie array that we already returned and go on. And the way we keep the responsiveness is that once we get to this await point, we immediately return. We come into the method, do our setup, and then as we kick off that request, we give back this task of movie array immediately to our caller and let them hold on to this handle and wait for the rest of the results to come through. And so, all right, we did that. Now we go back up to load movies. So remember, this is where the problem was before. Load movies started to become incredibly complex. So I'm going to go here and say, all right, well, query movies. I know I have to call query movies async. But remember, we didn't change the argument list. All we did was go back and say, all right, it returns a different type. So that means that here I'm going to want to await that. And to await something, I make the method async. But that's all I had to do. And you notice, importantly, I still have my while loop. So I got to keep my while loop, and now I've shifted all that work off onto the compiler. The compiler is going to do that job for me of figuring out exactly how you let me leave here, relinquish control, and then somehow come back exactly where I left off in the calling method. And I don't have to flat my while loop. I don't have to make a bunch of weird Lambda expressions. I don't have to make 2 methods. I just get to keep all my control flow constructs that I'm used to, and everything works out. And so I'll run this again, now that I've added just async and await to 2 different methods. I now type in a year again. And then when I do a search, you notice the UI is now responsive. I can move the window around. I can scroll. If I search again, I can scroll while the results are coming back. And then finally the results are done. But I didn't have to wait until they were done to do things with my application. So there we go. I'm able, with adding just 4 keywords, I'm able to turn synchronous code that I have into asynchronous code by calling these task returning methods and having the compiler do all that confusing state machine work that I really don't want to do anymore. But we saw also the really painful part before was exceptions. So how do we deal with exceptions in this world? Well, if I go here and I think, all right, where could exceptions surface? Remember, they were going to surface from the actual request before. Maybe they could surface during XML parsing. Or maybe the act of actually just getting the data out of the object was actually going to surface it. But all these different things here are now in the same method. And they're all just going to surface an exception from the same place. And so just like you handle exceptions in synchronous code by putting a try-catch around sort of as large a region as you care about, I actually can just deal with all these errors in the same way without any plumbing. And in fact, I don't even care to handle the errors here. I'm just actually going to let errors from any of those sources bubble out naturally from the method. Besides handling besides task handling movie arrays, it's also going to handle the exceptions that surface. Tasks can also deal with exceptional states besides completed states and say, hey, I'm a task, but the operation I was tracking, it failed, and so here's the exception that represents that failure. So I don't have to do anything. We have that capability already. And so assuming an error actually surfaces from there, when I await query movies async, that error will resurface in the parent method. And so I'm able to get the kind of natural exception flow out of methods, and I don't have to do any plumbing to make that happen either. So that's fine. So that comes out here. I want to do now just a try-catch and say, all right, well, if we have an exception, then go ahead and update the status text. I'm just going to say error occurred. And we'll put a little error in here to see what happened, and I'll say, all right, if this is not the first page, then go ahead and corrupt the data. So we run this again, and I do this. And we get one page in. Well, it stops. Well, I'm not sure why I didn't put the error, but it does actually stop, and it doesn't actually crash the program, even though, so I got one page in, and it managed to halt execution. So, all right, so that works. We have error handling working. I'll get rid of this so we don't keep that in there. But what else can we do now that we have exception handling? Well, we can handle cancellation. Remember, sort of with great responsiveness comes great responsibility. If you're going to actually have an app that is now responsive while you're moving the mouse around, while you're dragging the scroll bar, you have some extra things that you can take care of now. You can let the user cancel your operation. They're not required to wait for the whole thing to finish before you can do that. So I'm going to go back up here then and say, all right, well, what do I want to happen when the user clicks the cancel button? So we have this concept of, in .NET 4.0 is another thing that was introduced, of cancellation tokens. So it's this way that you can sort of track cancellation across this deep nested tree of operations you might have kicked off and operations they kicked off. And the idea is that an API like download string task async that supports canceling a request, like an outstanding network request, would support me passing it a cancellation token. So you see here, query movies async supports me giving it a cancellation token here, so I'm going to do that. And what that means is that I make this method accept a cancellation token. And so I say here, cancellation token, CT, and I pass it through, and that works fine. All right, well, so basically just by funneling that token through, I've now made query movies async a method that itself supports cancellation. And so how do I pass that through from here? All right, well, I just expect here that I'm going to have to pass something, a cancellation token. Where do I get one? Well, I get one from when I kick off this top-level operation. I go ahead and make myself a source for cancellation tokens. So I'll say up here, I actually want to store cancellation token source CTS equals null for now. And then when I kick off the operation, I'm going to say, make me a new cancellation token source. And then basically all this means you think of cancellation token as the light that lights up to tell you that we want to cancel. Cancellation token source is the big button you push that actually causes cancellation to occur and causes the light bulb to light up. So I'm just going to say here, pass in that source's token. And then when I'm done, clear this out. And the one thing now is that I could say here, well, if I want to catch something, I could say, well, catch task canceled exception. And just ensure that when cancellation occurs that I'm able to handle that and not blow up. And then when I go up here and I talk about cancel button, what happens when you push the cancel button in the UI? Well, I'm just going to say if there is one of these sources, if I've got one, then go ahead and cancel it. And then clear out the source. And I guess you also might as well just say here status text, text equals canceled so people know what's going on. So if I now go here and I type 1950, and I do a search, I'm starting to get stuff, and I click cancel, and you see that status text still doesn't like to update, but we at least canceled the operation, right? And so I'm no longer requesting results. I could go off and do something different with the UI. I could navigate somewhere else, and that works fine. So in the interest of time, I'm actually just going to skip ahead to one cool thing, just so we can keep everything on track. Sessions are shifting a little bit later. The one thing I have here is sort of the same app written for the Windows Phone. And so I'll actually run that inside the phone emulator. And you'll see this comes up, and it has a similar UI to the one that we just saw before. And here it is, almost. I come up here, and I'm able to search for 1950. And then, I've already made this one asynchronous, and it's really designed the same way that as we're searching, this is coming up. But because it's asynchronous, we can actually make this kind of really neat responsive phone UI. So I can search for 1980 and see that while this is coming up, I'm able to, don't want to tap on it because then we'll actually navigate, but I'm able to scroll and have that load. But then while I'm scrolling, I can go up here and go back and type and then search for another year and then have this year be loading while this other year is still loading. And I'm able to actually load all of these things at once and have these different parallel flows executing. And I don't have to think about managing these flows and, what do I keep track of all of them in some data structure. I'm just kicking off parallel things that are operating against different structures in the UI, and they're all multiplexing on the UI thread. And I'm able to do all this and stay responsive because I'm using asynchrony. And it's able to be easy because I'm using async and I'm using await. So let's go back to the slides. And just to get a better sense of how this control flow works, I'm just going to walk through exactly what is going on under the covers with these tasks so you can see what's happening. Async and await sort of seem like it's just doing a lot of magic, but there's actually something meaningful and deep under it that makes sense. And really what it's about is about making this good use of the UI thread. So we'll use this timeline, we'll represent the UI thread, and we'll think of all the different stuff that's happening there. And really what you need is, besides a thread, you also need some sort of dispatcher, something that's going to be scheduling work onto that thread. So if we're in Windows Forms or in WPF or Silverlight, you're going to have some dispatcher, some message pump that's scheduling all your work that you put on the UI thread. And that's what this is on the left. So let's say somebody calls do work async, right? You see there's two methods, one called do work async that is going to call process feed async twice. And then inside process feed async, we're going to go download a feed, parse the feed, save it to disk, and then we're going to write some log. And afterwards, we're going to come back, only after we've done all those steps, right? And so let's see what happens. Well, execution comes into our method, and we get to process feed async. So we get to that first call. All right, and we're going to call in. We're going to call into the method, and we're going to say, all right, I'm calling process feed async. And the moment you get into process feed async, it's going to return a task. And so it creates that task for you. It says, all right, this is going to be a state machine method. We know we're going to need a task to return when we get to that await. Let's make the task now. So we've got a task. So now we get into process feed async. We're up to the download feed async call. So we call that. And that goes off, and it makes a request saying, all right, download this feed from the web with a URL. It might take 10 seconds. Who knows how long it's going to take. But in the interim, that download feed async method itself is returning a task. You see, that's the box that we have on the bottom there. And so then we, though, said, OK, we're going to await this task. That means that this method is then going to return. Process feed async is going to pause its execution and return its own task back to the caller. So you saw when we said var t1 equals process feed async. Well, at the point we get to the await, now that task is returned back, and it's been stored in T1. And process feed async is now paused. It's not executing anymore. It's not even on the call stack. So now we're continuing execution through do work async. So we get down to the next line. And we get to the process feed async call. And that goes into process feed async for the next URL. It goes in there and says, all right, download the feed. That gives back its task, which you see on the bottom. We await that. It returns back. And then the process feed async task on the top is now stored inside T2. So every time you're calling one of these async methods, it's always making this task object, and then it's giving it back to the caller the moment that it's waiting for something else to happen, and letting that caller go on and use that object to track completion. So now we have two download feed async tasks on the bottom and two process feed async tasks on the top. All right, so now we're still in do work async. We've become responsive again, and so we're going on. We're going to say here, task.whenAll. And task.whenAll is this, what we call it a task combinator. And it's a method that lets you operate on a set of tasks, combine them, and do something together. So in this case, we're going to make a new task that only completes when all of the constituent tasks that you gave it are complete. So when T1 and T2 are done, then the task returned by task.whenAll will be considered done. And so we see that new task over there, the third task on the top. And then because do work async here is awaiting, it itself is going to return. And then that's it. The UI thread is now free. Seconds are elapsing. Downloads are occurring, coming back to our device. So now let's say one of these downloads finishes, right? And it could happen in any order. So we'll say the second download finishes. So the second download is now complete. It wakes up and says, all right, it's time to schedule my continuations. But the compiler has wired these continuations up for you. And so the continuation for download feed async in this case is just going to be, remember, the rest of the process feed async method. This is the kind of stuff I didn't want to be in the business of doing manually, figuring out here's a delegate, this calls into that. The compiler now did it for me and said, all right, well, whenever that download feed async task is done, go ahead and continue executing process feed async. And it does. We move on. We assign the text back. We start parsing the thing. We save it. But then you see that save.async is another method that we're choosing to await. So here we go. This is going to pause, wait for that to happen. Eventually, that finishes. In this case, it finished before the first download did. So that finishes. We resume. We move on again. So now we're doing process log.writeEntry. So every time we have this await, our method pauses and returns back to the message pump, and then only wakes up again once we actually have something to do. And all right, so process log finishes, and that means that the process feed async method itself is now complete. And so because that's done, that means that our T2 task that we returned all the way back at the beginning, that's now marked as completed. And so it can now signal its continuation of the compiler wired up back in the do work async method, right? But remember that we had passed T2 on to task.whenAll. We're not awaiting it directly. We gave it to this combinator that's going to track it. So the combinator says, all right, one of my two tasks is completed, but I'm still waiting for the other one. And so I now go ahead. I see, all right, well, the first task completed. I have download feed async. It's done. I go through all the rest of the same stuff again, right? So the process feed async is continuing to do its parsing, it's saving, we await for that, come back, right to the log. And then now that we're done, process feed async has completed. So T1 is now marked finished. Each process feed async task has now been marked completed because it's done its job. And so now that those two things are done, remember task.whenAll is tracking both of them. So now it says, all right, well, I'm going to mark myself as completed. So my job is done, making sure these two things finished. And so remember, do work async is awaiting task.whenAll. And so when it's completed, it's signed up as a continuation, the rest of do work async. And so now that finishes. And so you're able to smoothly bounce back and forth between your different methods by just saying, hey, here's what I want to return. In this case, it's not a value. It's just saying I want to track completion inside process feed async, and so I'm returning task. But by doing that, we're able to make sure that the first method waits until all those things are actually finished before it wakes up again and does its job to output done or whatever further processing it would want to do. And so if we look at how this works under the covers, I'll go through this a little quickly. We'll just say here, all right, well, I'm doing a simple thing saying download string task async. This is like the code that we saw before, and I'm going to parse it. And I have my await in there. Well, what you'd expect and what you can sort of mentally think of the compiler doing is this, right? I'm going through, getting to the point where I have my await, and then I'm saying task.continuewith. That's that way you would manually schedule these continuations. Maybe I'm saying task.continuewith, and I'm going to move on and say here, var text equals task.result, go do the rest of my method, right? But remember, that works for very simple things like our query movies async method we had, where I can say the first half of the method and the second half of the method are linear and just have one call into the other. But this would fall over once we get to a while loop, anything even a little bit more complex than this. So you can think of the compiler as doing this by just talking about the rest of the method, but to be general purpose, it can't actually do it directly this way. So what it does instead is it calls something like this. You don't have to read this and figure it out. You can check out the slides later if you're curious. But the idea is that it's actually breaking your method apart and turning it into a state machine. And specifically, if you look, you can see that the code that we wrote is still there within the state machine that it generates. But around it is all the code that's going to let this method pause and then come back later. So for example, after we get in here, you see that all of this code that we wrote is now inside this resume delegate that it created. And it starts executing through it. But then after we've downloaded the string and we get to this get awaiter part, it's then getting the awaiter, testing for completion, setting state to 1. That's pretty important. And then returning. And what it says there, it says on completed, and it passes that resume delegate. That's saying, hey, when you, as a task, when the download string task completes, go ahead and continue this method, resume there. And you notice the thing it did right before it called that was to set state to 1. So a minute later, the download's done. We come back. We come back at the beginning of that whole bracketed delegate, but the reason we jumped to where we left off is because state's 1, so that at the very top we have if state equals 1, go to L1. We've got a jump table at the top that lets us pick up where we want to later on. And so by doing that, by coming down below, I'm then able to continue. I have my result. I call a1.getResult, and I'm able to keep going. And so I didn't have to do any of this, right? This starts to look like maybe the kind of stuff I need to do to make this kind of system myself, but I didn't have to make it. The compiler was able to code all this for me. I just get to think in that same synchronous kind of way, even though I'm getting the asynchrony. What we like to call it is sequential but discontinuous programming. You get the benefit of asynchrony without a lot of the complexity. And so the idea really is that we're going to have this kind of support in .NET 4.5 throughout the .NET framework. It was made possible by the task parallel library from .NET 4. But then we're really having it permeate everything in the .NET framework. You're going to see it in base class library types, like the networking types, if you're using streams, if you're using downloads. If you're doing Windows Communication Foundation, setting up Azure services and having them communicate with each other and with your clients, that would work. Reactive extensions has all sorts of cool stuff for streaming data down when you have streams of events that are coming in, you want to pipe them to each other and process them. And that has a really good async interrupt now in their latest version. And we're going to support this in all the languages, right? We're supporting this in C# and Visual Basic. And this has actually evolved from a feature that shipped already in the existing version of F# async workflows, which are out there and that they're adapting to support tasks as well. And then it's going to be supported in all the platforms, right? So if you're writing desktop apps in WPF, if you're writing Silverlight apps, potentially for the phone. And we didn't cover it here, but if you're doing scalability on the server and you want to keep your response threads happy, you can go ahead and use this kind of stuff there. It makes it much easier to write asynchronous pages or use some of the new ASP.NET models that are coming out that are heavily based on asynchrony. So just in the interest of time, I'm going to skip ahead here, and we're going to finish up because we're a little bit over, but I'm just going to jump ahead and show you one cool thing with Project Roslyn. So the stuff that I showed you here, just as sort of a call to action, the idea of asynchronous methods, it's really just to make your programming as simple as synchronous code. It unifies all these different kinds of asynchrony. The network asynchrony you're going to do, if you're reading from files, if you're doing CPU-bound stuff, all that can be represented as this task type. And it helps you also make more scalable servers. So on the client and on the server, you get everywhere this benefit of asynchronous programming. And so if you guys like this kind of stuff, this is sort of a whirlwind opening tour of this. If you want to try this out, go ahead. We actually have a CTP. We'll give you the URL in a bit that you can download the Visual Studio Async CTP and try this out. The other thing is you can also download Visual Studio 11, the developer preview. So this was given out at Build. It's been available for a few months now. So the Async CTP installs on top of VS 2010. But if you're feeling really adventurous and you want to install VS 11, you can go try it there. And that's an even newer version of Async that has a lot of the perf work that we've done since the Async CTP. So in sort of another 5 minutes, I'm going to show you one more cool demo before we're done. And it's sort of looking even further into the future of C# and Visual Basic. So we talked about what was going on up to now and then all the asynchronous programming stuff we're doing. But what are we thinking about after that? And what we're thinking about is something we've called Project Roslyn. And just describing it by example, sort of you think of today what a compiler does. Really the purpose of a compiler is obviously takes source code in, spits out binaries. And in the process, it's getting a whole bunch of awesome data about your program and tokens and everything like that, but it just uses it and then throws it away, and once it spits out your assembly. So the idea of Roslyn is to rewrite the compilers in managed code. So we're writing the C# compiler in C# and VB in VB, and rewrite them and expose their functionality as APIs. So not only does the compiler have access to all this data, you do as well. And it starts to let you do all sorts of cool things, right? You can imagine ways you build meta-programming features, aspect-oriented programming, logging, things like that, which can actually modify the syntax trees. Redevelop print loops in case you've used like Python Interactive or F# Interactive. You can build those kind of interactive coding environments. You can embed DSLs. Imagine sort of a snippet within your code where you have this declarative syntax for whatever domain you're using. If you're programming robots and you have some unique language you wanted to use to actually interact with that, you could have a whole structured app inside C# and have bursts of your app that have meaning, that can actually be compile time checked, that are in this alternate language. And then language object model, just actually making this available so you can write IDE plugins and actually have a lot of awesome introspection into your code. And that's the last thing is what we're going to take a look at quickly. So I'm going to go here now and, just 1 second, take a look at a demo. I'm going to go to the third demo here. And you see that I'm in VS, but when I hit run, I'm actually loading another copy of VS. And that's because what we're doing here is we're going to be creating, in a few minutes, just a quick IDE plugin that bakes in, that uses the Roslyn APIs to help you out when you're editing. And so you can see I'm loading this sample solution here. And it's just a simple program. It has one method. But I'm using the outlining features here, and I'm able to collapse and expand that one particular method. And that's what you do today in the VS IDE. You're able to collapse and expand methods. But let's say I want to do more. Let's say I want to make it so I can collapse and expand all my if regions, right? I have a whole bunch here. I might care to do that. So let's see what that would entail. I'm going to close this second instance of VS. And so if I look here, what I'm making is I'm making this outliner type, and it's implementing this interface iSyntax outliner. That's this Roslyn interface. And this is one of these things that's going to let me plug into the IDE. So just first, I'm going to pull in a little helper method that I need. And this is going to say create region. This is going to let me go ahead and pass a start token and a certain node and make a span that I can say here is the actual span that I want to affect with my outlining. And then inside here, I have this method I'm implementing. You see get outlining spans. And the idea of get outlining spans, Roslyn's going to call into me and say, hey, by the way, here's a node. Do you happen to want to outline anything inside this node or inside this, inside this particular node that it gives me? And so currently, we're just returning an empty list, so it doesn't really do anything useful. But let's start adding some stuff to here and say, all right, well, let's check out this node. Let's say, by the way, we've already set up above, we've already set up above that we only want to be called for nodes that are if statement syntax nodes. So we know it's an if node. So we go here and we say, all right, cast it to be an if statement syntax, and start looking at it. Say, all right, if, get the statement, see if it's a block syntax, if the if actually has a real block that's worth collapsing with braces. If it does, say results.add, and get the last token from the region, and then make that a span, and make that a region that we want to make collapsible. And that's really sort of all we have to do for the if blocks. The one other thing we want to do is handle else blocks also. So I'm going to go here and say, all right, if this particular if node has this optional else part, then we go forward and say, get the else block in the same way. See if the else block is not null, and if it isn't, then go ahead and add from the else keyword on and make that a collapsible region. And that's all we have to do. In each case, you see we're adding that to this results list, and then we're going to return the results list back. And then I go in here, I run this again, and I call presence here. And we'll see if this works. So as the outliner loads, you see we have this outlining, but we now also have the outlining on all of our if regions and all of our else regions. And Roslyn is able to give us intelligent stuff. It's able to provide a tooltip for us. We didn't have to think about providing that. We just specify the spans that we wanted to handle. And so that's just sort of one really quick taste of something you could do when you have this rich access to the language model. You don't have to think about parsing and doing that stuff yourself. And sort of just as one last fun trick, if I actually copy all this code, you see I have another VB project here. Let's say I really wanted to write this for Visual Basic or write this in Visual Basic and poke around there. When you have access to the Roslyn APIs in this way, you can also write sort of more interesting tools in this, let's say one that converts C# to Visual Basic. And so I click paste here, and it takes the code that I put on the clipboard, and it analyzes it and translates this over to Visual Basic and pastes that in. And it's smart enough, given the Roslyn APIs, to know, well, in C# you can use an end as a keyword, but as an identifier. In VB, end is already a keyword, so it has to escape that identifier for you, right? So you're going to have to write some code to actually map a lot of this yourself, but Roslyn really helps you. And it's far easier than if you had to parse this code yourself and actually do all this kind of tree manipulation. So the other call to action, go ahead, download the Roslyn CTP. If you're sort of interested in this kind of stuff that's going on, if this piqued your interest and you want to think about your favorite language feature or your favorite IDE feature you've always kind of wanted to be there, this is the way to kind of try that out and make that a reality. So you can go download the Microsoft Roslyn CTP. It'll plug into Visual Studio 2010, and you'll be able to poke around the same way we just did. So here are the general links. You can find all sorts of stuff up there at that first link. But more specifically, if you really want to try out the async CTP, it's an easy URL to remember, msdn.com/async. And you can give that a download. You can try it out again. It installs cleanly inside VS 2010. And if you're into Roslyn, if you want to try that out, msdn.com/Roslyn. And so you can try these out. I have them both installed on the same laptop, and I still give demos on it, so I trust it. And that's basically it. Thanks.